You flip the switch. The coal burns in the furnace, converting water into steam. This steam drives a turbine, which in turn drives a generator. It causes electrons to flow through the wire. This current travels hundreds of miles through electrical cables. And it arrives at your house. Every second, thousands of people around the world do this. By turning on the computer, connecting it, or pressing the play button. So, how much power does humanity require? The total amount we use fluctuates rapidly. So, in response to this question, we need to know more than just how much energy the world consumes today. But how much will we use it in the future? The first step is to learn how to measure electricity. It's a little tricky. A joule is a type of energy unit. But we don't usually calculate electricity in joules. We instead measure it in watts. A watt is the amount of energy required to power something for 1 second. 1 watt is equal to 1 joule per second. It takes about 0.1 watts to power the HatSmart, 1000 watts to power your house, and 1,000,000 watts to power a small town. A medium-sized city would require 1 billion watts. It will take 3 trillion watts to power the entire world in 2020. However, nearly 1 billion people do not have regular access to electricity. More people join the network as countries become more industrialized. Electricity demand is expected to rise by approximately 80% by 2050. This figure does not represent the entire picture. We will also have to reinvent how we use electricity. Many things are currently powered by the combustion of fossil fuels, which emits an unsustainable amount of greenhouse gases that contribute to global warming. These emissions must be completely eliminated to ensure humanity's long-term future. For many industries, the first step is to switch from fossil fuels to electric power. Cars will need to be converted to run on electricity. Convert natural gas-heated buildings to electric heat pumps and convert the vast amounts of heat used in industrial processes to electricity. Overall, global electricity demand could triple by 2050. We will also require that all of this electricity be generated using clean energy sources. If it solved the issues caused by fossil fuels, only 1/3 of the electricity we generate today comes from clean sources. Fossil fuels are inexpensive, convenient, and simple to transport. It is simple to convert to on-demand electricity. How can we bridge this chasm? Wind and solar power work well in areas with a lot of wind and sunshine. However, we cannot store and transport sunlight or wind in the same way that we do oil. To fully utilize the energy from these sources at other times or in different locations, we must store them in batteries and upgrade our power grid infrastructure to allow for long-distance transmission. Meanwhile, nuclear power plants generate carbon-free electricity through nuclear fission. Despite being more expensive than plants that use fossil fuels, it can, however, be built anywhere. It does not rely on intermittent energy sources like the sun or wind. Researchers are currently working to improve nuclear waste disposal and nuclear plant safety. Another possibility that has eluded us since the 1940s is nuclear fusion. It entails smashing light atoms together until they fuse and make use of the energy it generates. Nuclear fusion is not concerned with accidents. It does not result in long-term radioactive waste fission. It also has no transportation issues relating to wind, solar, and other renewable energy sources. A significant breakthrough in this area could revolutionize clean energy. Nuclear fission, solar energy, and wind energy are all examples of this. Mutations in any of these technologies, especially when combined, change the world. We not only tripled our electricity supply, but we also managed to sustain it.